Right. Good morning, everyone. I'm Anthony, faculty member in the Department of Civil and Environmental Engineering in HKUST. So I'm here to report back our workshop about excess water challenges. So before I talk, I would just like to show you a video first.
바로 앞에 있던 차량들이 순식간에 사라졌습니다.
So I couldn't translate it, but you could see properly what happened.
여씨는 급히 제동 장치를 밟았고.
So that is in Taiwan, very close to us. Another landslide. Okay, so we have a lucky guy over there. Yeah. Wow, scary, huh? So similar event is like a mud flow in the state. So basically, the whole village has been flushed during excess rainfall. And probably you could recognize this 10 years ago, we have a severe debris flow happening in the Lantau Island. So that is the access, the only access to our international airport. So after this event, the whole highway has been blocked by 16 hours. Pretty scary. So what does that mean about excess water? So from the previous presentation about from the climate researchers, we know rainfall is going to be increasing in the future. So what does that mean to us? Landslide density will be increasing. That's the statistics provided by our colleague in Geotechnical Engineering Office in CDD. So that's the prediction. And we also have academics in HKUST doing the prediction of what happened under the climate change scenarios. And this is the western part of the Hong Kong Island. As you can see, these little tails here are representing the debris flow event under some sort of climate change scenario. So we don't only have the landslide events, but also flooding. As you can see, the blue areas, those are the potential flooding areas in our future. So that is not only happening in Hong Kong, but also in the Guangdong, Hong Kong, Macau Bay Area. So from the statistics from our insurers, Swiss Re, they show that this is the #1 risk population in this area with storm surge, and also the flood. So that is not only happening in Hong Kong, but in a greater Bay Area as well. So we also have colleagues from the Drainage Services Department sharing their current technology in Hong Kong. So they have a very innovative approach. So they are trying to build a spongy city. So by building this kind of blue-green infrastructure to adapt that kind of climate change future regarding flooding through different mechanisms, as you can see, okay? So we also have speakers from GEO, the Geotechnical Engineering Office, sharing the current smart approaches to sort of communicate with the community about the debris flow event. So this is what they call the debris impact switch. So we have a check them to collect the debris material. So there's a sensor sending message to the mobile app, so to warn the system. So this is still under research. It's a collaboration with HKUST, with the GEO. So can we do better? So those are the existing technologies. So we have ongoing research on developing more adaptive infrastructure for landslide. So this is one technology, they call it flexible barrier system. So basically it's the steel wire to collect the debris. So the HKUST colleagues have built a long flume. Okay, so by collaborating with the University of Hong Kong Kadoorie Center, so they built around 30-meter long flume. So what they did is, here I show you some video. So that is a video showing looking upstream. So basically we collect a debris and then we open the check, and then where is it? Okay, so no, not this one first. Look at that one. So debris coming down. So if you look downward, you then see the debris going through. So you see the piling up of the debris because of the flexible barrier. And if you look at the right-hand side here, so the debris is coming down, and we have one layer of flexible barrier, another one. So if you can see here, we are trying to minimize this runoff distance, which is very important because in Hong Kong, we are very densely populated. The infrastructure is very close to hill. So if we can minimize this runoff distance, then we can save lots of life. So this barriering system seems to work quite well, and that's the recent research. And we also have speakers from overseas, in the UK particular, from University of Sussex, which is Professor Michael Davis' work, which is in the audience here. So he has a very innovative or ecologically friendly approach to stabilize slope using vegetation. So these are the root systems. So why don't we utilize this root as engineering materials or engineering structures to stabilize the slope? So this is one thing we could probably learn from the overseas. So challenges is about materials and then systems are deteriorating with time. So even though we build something new today, the performance increase. But as the time goes, perhaps due to the environmental loading, because of the climate change, things deteriorate. Okay, so it may drop below the performance level. Okay, so what does that mean? So even we build a very perfect system today, after 50 years, the system may deteriorate, just like your photocopier in your office. If you utilize it a lot, it deteriorates, then you need to replace it. So what does that mean? So for the increased rainfall, we have challenges. We need to improve our adaptive system for this kind of events. Okay, so it's quite challenging in terms of research to predict where and when that failure will happen with time. Okay, so this required a lot of research in understanding the interaction between climate, soil, and also possibly the vegetation. So it's a cross-disciplinary research. So the next step here is we are trying to collaborate quite a lot with engineering, the government departments, including the HKO. So we are trying to develop a research project looking into more details, using more latest advanced technology like the AI, the machine learning. So we try to collect the historic data to predict better what happened in the future and then develop our physical infrastructure more adaptive. So I would like to end my presentation by sharing one of the slides provided by the Geo colleague. So it's not only engineering job, but it's collaboration with all these parties to make our city more resilient. Thank you very much.